Okay, this is still section 4.3, but we're only going to look here at synthetic division in this example. So here is my first example of synthetic division, and you've probably learned in the past how to take higher order polynomials and divide them using long divisional techniques, but there is a quicker and easier way to do it with synthetic division. So we're going to look at this example here. Use synthetic division to find the quotient and remainder of this problem. Okay, so what you do in synthetic division is you set up and you make sure that this is in decreasing order. So you always have to have it in decreasing order. If you have it mixed up, then it doesn't work. And then you also have to always equal this here part, your x by your binomial part, solve for x as if this is equal to 0. So the first thing we're going to do then is you make a little L like this, and then you put all the terms here. Make sure you put in signs. And leave some space underneath. I didn't leave enough, so I'm just going to extend my L there. And then what you do is, well, if x was equal to 0, or x plus 4 is equal to 0, you'd have a negative 4. So put your negative 4 there. And then you would just simply divide as if you were using long division. So bring down here this number. Then you go negative 4 times 3. That's negative 12. Okay, then you add these two together. So add always. Add these two together would give you a negative 7 here. Okay, so then you would multiply negative 4 and negative 7 multiplied together would be a positive 28. And then you would add those two terms together, so that would give us 21. Again, using the same step, negative 4 multiplied by 21 would give you negative 84. And here we would combine them to get negative 81. So this would be our remainder, and this would be our quotient. So our quotient, I'm just going to check the field of view, make sure it's still in there. Okay, good. Our quotient in this case is, you would take one of these x's off, so that would be 3x squared minus 7x plus 21, remainder negative 81. And that would be an example of how you use synthetic division. Remember, with synthetic division, take your binomial and equal it to 0 and solve for x. That goes in there. And make sure that your polynomial is in descending order of the x powers. And then also remember, you would multiply, put the number, and then add. In this case, some books do it the exact opposite way, but this is the way that your book follows. So we're going to stick with it. So I'm going to do a second example that would use one that might have some fractions in it of synthetic division here. So let me just make sure that's in the field of view. And my second example is find again the quotient and remainder using synthetic division. So I want to take 16x to the 4th minus x cubed. I'm going to put it in the right order here. Plus 2x cubed, squared, minus 8x plus 1. And I want to divide that by 2x plus 1. Okay, so what we do with synthetic division is we say, well, 2x plus 1 equal to 0, so that's going to give us 2x equals negative 1. So x is going to be negative 1/2 in our synthetic division setup. And then I put in the terms 16, negative 1, positive 2, negative 8, and positive 1. So then I start with 16. bring it down. So negative half times 16 is negative 8. Negative 8 plus negative 1 is negative 9. Negative 9 times negative a half is positive 9 halves. So 9 halves plus 2. So you have to think of 2 as 4 halves. Okay, so this would end up giving us, if you think of this as 4.5, it would give you 6.5 if you want to use that decimal way, but we just want to stick to fractions here. That would simply be 11, or sorry, not 11. That would be 13 halves. Okay, so 13 halves multiplied by negative 1 half is negative 13 quarters. Okay, so again, we're going to add here. Now, negative 13 quarters is fine, but we have to change the 8 into quarters. So that would be, well, 4 times negative 8. So this would be like saying that this here is negative 32 over 4. So that would give us 32 and 13 gives us 45, negative 45 over 4. And our final step then is to multiply by a half again. So we get negative 40, or positive 45 over 8 this time. A little easier this time to remember that 1 is 8 over 8, so that would simply be 45 plus 8 over 8. And in our case, that's 53 over 8. So you can get fractions. So there's our remainder, and our actual polynomial quotient is 16x cubed minus 9x squared plus 13 halves x minus 45 over 4, and the remainder in this case is 53 over 8. So that's synthetic division. In our next section, we're going to be specifically looking at factoring. It's going to be the same section again, but it's going to be the third part of it. And it's going to be specifically looking at factoring out high degree examples or high degree polynomials to work them out completely.